All right, so this is session 7, which is tonight is session 8, but we are doing session 7 because we rearranged things for Tom to come in and talk about the ways to get into Code Platoon. We're going to cover 2 concepts tonight. The first one being Truthy or Falsey. And does anyone have any idea what Truthy and Falsey is off the top of their head before we dive into it?
Does it have to do with like if-then statements?
It does. And what it does is that basically all values in JavaScript are either inherently truthy or falsy. And the vast majority of them are truthy, but there's a handful of them. So false, 0, an empty string, null, undefined, and nan are all falsy. And so we haven't gotten into it too much, but we'll take a look here. So this is one that I just kind of drew it up with an empty array, right? And so we've got an if-else statement. Now, instead of having like a comparison here, like is greater than or less than or equal to 0, something like that, all we're doing is we're letting this value or this variable either resolve itself to true or false. Now, an empty array, right, is, if we look back here in the slides, is a default of truthy, right? So empty array, an empty object, an empty function are all truthy. Anything, a string containing a single 0 is truthy. Pretty much any string, anything where there's actually something there is going to be truthy. So like right now, but we know that a empty string, right, this is going to be false.
I think it happened again.
I can hear you.
Okay, there we go.
Okay. All right. So, all right. I'm on pins and needles over here, guys. I'm sorry. But one sec here. Let me just Slack Tom. All right. And so what we have here is an empty array is going to, when I run this through, we're not comparing this to anything. We're just allowing this to resolve to its inherent value. So me putting an empty array in here is pretty much the same thing as me putting this in here. That's what that resolves to. Right. And so, and if I do the same thing down here, though, right, this, an empty string with nothing in it, is going to, with a spelling error, are going to resolve to falsy, right? And so I can take the number 0 here, right? And that's going to do falsy. But if I take it and turn it into a string, right, now that's truthy. Okay. And so trying to memorize everything that's truthy is hard because there's this basically, it starts with empty, and then also anything else is going to be considered truthy. So like an array with objects in it is truthy, and a non-empty object is truthy. You just need to remember that these six things are falsy. And to the point of there's no standardized testing for being a computer programmer. So all you need to do is Google JavaScript falsy values and you'll get this list. Or remember that you've got these slides. And so there are the using truthy and falsy values is popular in a style of programming, or kind of like a pattern called short circuiting, where like let's say that let name equal that, and then I say oh, let's see here. We'll do, I'm trying to think if this is going to work in vanilla JavaScript, but we'll see here. Let me just take this, comment that out, right? And so, yeah, and so this worked. And I'm getting an internet connection unstable, so we'll see what happens. So what happens is that I don't want hello nothing to appear here if I don't have a like a name, right? So inside my program, if there's no name specified, if there's no username, I don't want it to say just hello. I always only want it to say hello Charles, or hello Jeff, or hello Courtney, right? And so
Man,
what I
so
can
close.
do, what's that? Okay. Everyone can hear me. We're still on track.
You're cutting in and out.
Yeah. So you're cutting in and off. You'll say a sentence, you'll start it, and then you won't finish it. Like all the vital stuff.
Awesome. Let's see here. Sorry, just one sec. Let me pause recording again. Okay, and sorry. So to backtrack a little bit here, what I'm explaining is short circuiting, and short circuiting is using the inherent truthy or falsy value of a variable, a piece of information that we can then use to short circuit the display or lack of display of another part of the program. And so for instance here, if I just have a simple thing that I wanted to say, if there's someone's name, say hello name, and if there is no name, I don't want it to say anything at all. So I could wrap this in an if statement, or like a ternary operator, something along those lines, and do that. But the easiest, most concise way to do it is just to take your variable that you're using and put it in an and statement. Because what it's saying is that if both name is truthy and this is truthy, then you will basically then return it. But if one of these is false, you won't end up seeing either of them. So when I hit run, notice I don't get anything up here at the line. But as soon as I enter in a name right here, name is no longer an empty string, it's truthy, and so it's going to then display the whole thing. Does that make sense to people?
That does, but let me ask, if you were to put console log first and then name, would it log, would it type out hello?
I think it does, but we'll find out here. Normally, because you take the variable and you list that first because it's shorter. Let me do this. Yeah, so you still get the hello here. So you want what you're basically making this conditional on, which is that there's a value in name, to go first.
Okay.
right? And so that's just like a quick little demo on short circuiting. All right, so, and that's it for Truthy and Falsey. So now we're going to hop into the main event, which is recursion. And this is a different way of writing a algorithm. And it's not necessarily, it's not the common way of writing an algorithm. And pretty much any instance or problem that you can solve with recursion, there's an iterative way to do it as well. And typically the iterative way is going to be a more efficient way of doing it. Again, there are certain special cases, like there's functional programming languages like Clojure or Elixir or Elm, that with functional programming there is no looping, so there will be recursive functions that you're able to use, or like a built-in recursive case that you would use when you're writing in those languages. However, JavaScript, learning recursion and understanding the implications of it, why you may use it, why you typically wouldn't use it in production, is kind of like an academic exercise. So recursion is the process in which a function calls itself. So using recursion to solve a problem requires two cases, and this is very important. And I highly encourage anyone that is working with recursion that number one is always your first step, which is identify your base case. And that is the condition in which your function stops calling itself. So think of that just like in the for loop, like when do we start counting, or where do we start counting? How long do we count for? Your base case is how long do I recurse for, right? So once you hit a specific point, which is your base case, you will stop recursing and calling itself over and over again, and it will start to return all of the answers back up the call stack. Okay, so in the recursive case is the case in which the function returns itself. All right, so this looks like a big giant mess, and it kind of is. Okay, so what we have is, so I'll point out a couple of things here, right? We're going to do a call depth. So we see call depth 1, 2, 3, 4, and 5. All right, so the original call is let result sum up to 5, console.log result, right, is 15. So when we call this, so here is just the basic function, and oops, sorry, let me actually write this down inside the replet, and it'll be a little bit easier to understand. We'll go through this here. All right, so let's see here. That's the wrong one. Let's go back to here because that's got 5 loaded into it already. Okay, so when we do this, so I'll go ahead and console.log sum up to 5, oops, up to, and then 5, and this should return 15, right? And so what we're doing is we're adding 5 plus 4 plus 3 plus 2 plus 1, and that's how we get 15. So if I were to do, excuse me, sum up to 4, I would expect that my answer is 10. If we sum up to 6, my answer is going to be 21, right? And so it's just going through and adding that up. And what we're doing is we're basically creating a loop with function calls that will continue to call itself over and over again until we hit our base case. And so our base case is if num triple equals 1, then return 1. Else, we're going to return num plus sum up to, so we're calling it a second time, num minus 1. So bear with me here just a second. So if I call this with 5, what's going to happen is num gets replaced by 5. All right. So if I call sum up to 5, basically, or sum up to, and then put in the number 5. So 5 is right here, gets passed into the function. Does 5 equal 1? No, it does not. So we go to the else case. And what we're going to do is we're going to return 5. But before we actually return, we're also going to add sum up to 5 minus 1, right? And so what's 5 minus 1? It's 4. And so the second time that we end up calling this method is now we have this. Right? And so this right here turns into this down here. 5 minus 1 is 4. And so there's our second function call, just like how we called it the first time down here. And so this pattern is going to continue to repeat itself. Right? And so this 4 minus 1 is 3. Well, 3 comes in here. 3 comes in here. It is not equal to 1. We go to the else case. So now we have 3 and then 3. And this turns into 2. Right? And so now we're at 2. 2 is not equal to 1. So we skip this and we hit the else case. And we're going to return 2 plus another function call, which is 2 minus 1. All right, so now we've just called this. And so this is true, right? So we basically disregard that because we just hit 1. So we return 1. Well, now as we go back up the call stack, this turns into 1, right? So now this returns 2 plus 1, so that's 3. This turns into 3. Well, now we return 3 plus 3, that's 6. This turns into 6. We return 4 plus 6, that's 10. This turns into 10. Now we return 5 plus 10, which is 15. We're at the top of our call stack, so this ends up turning into 15. And so, and then we console.log it, and I'll throw an error here, but then we would get 15 over here. So I know this is a very different way to think about these things. Hopefully I didn't break up too much while I was talking, but are there any questions that I could answer about this or show you guys, like go more into depth in this?
What if it was the sum up to function before the plus 5? Would that change anything or no?
So can you tell me which line you're talking about?
Like the return statement, if it was return sum up to the variable and then plus 10. Does that make sense?
Right. Well, so we just keep going, right? So if I basically, let's say that like if I would have called this as sum up to 6, and that means that basically I would have started at 6 and I would have already worked my way all the way down through the chain, and I would have come back up and this one would have returned 15. and this would have resolved to return 6 plus 15, right? So it just goes another layer deeper. Is that what you're asking, or is there something else?
I'm sorry. Can you scroll up? On a
So it was line 27.
This?
yes, like if line 27 was return, if the num and the sum up to, if those were switched, that's what I was wondering.
I don't think it would matter. And we can call it here real quick. And maybe it does matter, but I don't think it will, because you're not returning it until everything reevaluates itself. So let me just go ahead and grab all of this and comment it out. And so this should still resolve to 21, and it does, right? Because I'm still just adding these two things together.
Okay, great. Thank you.
Yep. And yeah, and so it won't matter which order you do these. Now, obviously, you have to remember order of operations. Like if there was some multiplication involved somewhere, or something along those lines, then yes, I mean, the order does matter. But within this example, it does not matter. All right, so that's that one. Let's go ahead and take a look at, well, I'm going to walk through the free code camp examples as well. Right, and so write a recursive function similar to Rn that returns the sum of the first n elements in an array of R. Okay, so basically what we're talking about, and I'll show this. So the example they give you is multiplying the first n elements of an array. All right, and so if I feed in multiply, let me just comment that out, and I give it an array of 1, 2, 3, 4, and 5, and then I want it to multiply the first 4 elements, right? Whoops, 2, getting some parens here, right? I get 24. So I'm saying 1 times 2 times 3 times 4, right? So 1 times 2 is 2, 2 times 3 is 6, and 6 times 4 is 24. All right, so again, this is our base case, right? And this is our, I guess right here is good enough, our recursive case. Okay, and so what it's saying is if n is less than or equal to 0, just return the number 1, right? Because when we multiply any number by 1, it's that number. So 1 is kind of neutral in this. It's not going to impact the end outcome, right? And if n is not less than or equal to 0, then we need to return multiply r n minus 1 times r n minus 1. Now, this n minus 1 and this n minus 1 are not doing the same thing. All right. So, because remember, humans start counting at 1, computers start counting at 0. Right. So, if I come in here, this is the 0 index position. This is the 1. This is the 2. This is the 3. This is the 4. right? So if I want the first 4 elements, and because it's not telling me that treat this as index positions, it's saying the first 4 elements, I need 0 through 3, right? So all this is saying is start at the basically the index position specified. And to do that, I have to like subtract from 1, right? Because if I want the first 4 elements, I'm going to start at the 3rd index position. So this n minus 1 doesn't have anything to do with this n minus 1. And what's happening here is this is just basically specifying that where we're going to start counting. And so when I come through this the very first time, what's going to happen, and I'm not going to try and make as huge of a mess as the other ones, is basically I come in here, I put an n of 4, n is not less than or equal to 0, so I skip this return 1. I come down in here into my recursive case, and basically what I have is this, and then I'm calling 4 minus 1, and then I'm multiplying that by 4 minus 1, which is 3. So R in the 3rd index position, right? And so now I'm well, let me do this. Make this a little more readable. Right, so that is equal to 4. And so then the second time that I call it, I'm basically I'm passing in the exact same array again, but this time it's going to be 3 minus 1. And I'm going to look at R2, which is 3, right? And then I'm going to come in, oops. And this is going to be 2 minus 1. And this is going to be 1. And that's going to be 2, right? And now this time, this 2 minus 1, so this n minus 1, this 2 minus 1 is coming in, and I'm going to hit my base case. So I'm going to hit this, right? I've got, or I'm sorry, so it's going to be this time through, and R0, that's going to be 1. And I apologize, I misspoke. This is going to be my base case, because now I'm at 0 minus 1, and I'm going to hit that less than or equal to 0. And not, so I don't come down here and I don't call again. I actually just return 1, right? And so now this returns 1 to here, and I have 1 times 1, right? So then that returns 1 times 1, which resolves into 1 times 2, which resolves into 3 times 2, which resolves into 4 times 6, right? And so this is why recursion is, it's more resource intensive for your computer, because what happens is, as I travel down the call stack, basically I have to take this whole function and it's being saved in memory. And then I'm saving this whole function and saving it in memory, and saving it in memory, and saving it in memory, and saving it in memory. And then when I come down here and I finally hit my base case, that's when I return a value up into here. I return the value. This gets dropped out of memory. It doesn't need to remember the whole function anymore. Gets returned the value, drop from memory, return the value, drop from memory, return from value, drop from memory, all the way up to here, where you finally return the last value and you get what you're looking for, and that last function gets dropped. Now, this is linear because if I have 20 layers, right? Like, so if I say sum up to 20, I'm going to save this method into memory 20 times. Now, where it gets tricky is, let's say that I have something like this that is that looks something like this, where every time I recurse to a new layer, I have to do 3 recursive methods, right? So if I only have 1 layer deep, right, I'm still saving 3 methods into memory. Now, if I go 2 layers deep, each one of these is going to save an additional 3. So I'm up to 12 methods saved in memory. And if I go that 3rd layer deep, then like I don't even know what it turns into, but I end up with like 30 or 40 cases saved in memory. Now, let's say I take something that requires me to go 50 or 60 layers deep. You end up with millions of methods saved in memory, and you'll blow your call stack. And that's basically the same thing like an endless loop, or when you recurse too deeply, like you'll run your computer out of memory, and you'll run replit out of memory really quickly, and the whole thing grinds to a halt and throws an error. All right, so any questions on that one? All right, so let's go ahead and say write a recursive function, sum rn, that returns the sum of the first n elements in an array of R. Now, this is going to be very similar to this one, where we're doing the multiplication, right? However, with this one, we return 1, because if we return 0 out of here and we multiply a number by 0, then it doesn't matter how many more numbers we multiply it. Any number times 0 is 0. Now, if we're doing addition and we return a base case of 1, that means that we're going to end up rounding up or adding an additional number to all of our answers. So in that same instance, like if we're summing and I've got 1, 2, 3, 4, my answer is 10. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. But if I return 1 out of my base case, then I end up with 11 because I just tacked on an extra 1. So let's go ahead and do this. Okay, so first thing is we need a base case. All right, and for this one, the base case is pretty much the same, and less than or equal to 0, because we're decrementing downwards. But instead of returning 1, we want to return 0, because we can add 0 to any other number and it doesn't change the outcome of that number. Now, the else, and so this is our recursive case. Right, we want to return sum, same thing, R. So we're passing in the exact same array every single time. And we're going to decrement here by 1, right? And then same thing. This is our n-1, and the only reason we're doing the n-1 here is to convert it from length to index position, right? And so when I run this, I'm expecting that I would get an answer of 10, right? And I'm pretty sure since there's no sixth position here, right, I get not a number because we end up throwing an error when we get down to the bottom here. But if I were to say 5, so give me all 5 of these, then I would expect that I would get 15. 1 plus 2 plus 3 plus 4 plus 5. All right. How do we feel about that one?
Yeah, that one was pretty easy.
Okay. So, all right. So let's go ahead and we'll keep pushing here before we take a break. We'll knock out these other free code camp ones before we break into the challenges for the evening. All right. So the other one that we've got here is, let's see here. So the next one was doing a countdown, right? And so they give us an example of doing a count up, right? And so when I do a count up here, oops, right, I get an array with 1, 2, 3, 4, and 5. So, and what they're saying is they want to see something that looks like this, right? So that we're doing a countdown. So what, just thinking about this at the surface level, what are some easy changes we could make in this to basically do our countdown?
Swap out push.
Yep. So, because right now, push is basically just going in and adding the next value into into the array. And what we want to do is, since we're doing a countdown, we want to just keep adding it to the front, right? And so what we could do is say function countdown, and this again will look very, very similar to what we have here. So here is our base case. So if n is less than 1, right, and then we're going to just return an empty array. So we're not going to return anything. And so it just pushing an empty array into an existing array, it basically doesn't do anything. It doesn't change it. So we can say we'll steal the count array here, and we'll say countdown n-1, right? And so again, if we don't decrement here, and I just keep calling countdown n, like we're never going to hit our base case. It's like writing an infinite loop. And I'll pop that one out to kind of show what's going on here. So now, instead of just doing a pop, right? So if I do const array, so we called it, count array, unshift n, and then we go ahead and return the count array. Oops, sorry, I did not call it. Right, so there's our 5, 4, 3, 2, 1. Now, same thing here. So if I do not decrement, just like in a while loop, like where we have to increment or decrement so that we're moving closer towards our conditional for the loop that tells it when to shut off, we need to move closer towards our base case each case. Otherwise, we'll just go for forever, right? And maximum call stack size exceeded. That's basically a infinite loop for a recursive method. So max call stack size exceeded happened really quick, and the replit, because they're giving you a very small amount of virtual memory here. If I did it inside my like my VS Code, where I'm actually drawing on the memory off my computer directly, I think I've got 16 gigs of memory, so it would still blow up really quick, but it would last a little bit longer than what the replit did. Because I mean, maybe this one can hold 100 or 500 in the stack deep. Like my Mac can hold 2,000 or 3,000 in the stack, or maybe 10,000 in the stack before it blows up. So we always want to decrement, or I'm sorry, not decrement. We always want to move closer to our base case, right? And literally we're just adding it from a different direction, right? Oops, not pop, push. All right, so that goes forward, and unshift is doing it backwards. All right, so it's about 7:06. So let's go ahead and take a quick 5-minute break here. I need to drink some water, and then we'll hit the first challenge of the night. And I'll leave you guys a little bit of time to work on it, and then we'll check in on each group and then pull everyone back, and we'll go over it together. So be back here at 7:12 Central Time, and then I'll push us into our breakout rooms. It looks like we've got a crew of 7, so we'll have a group of 4 and a group of 3 tonight. Okay, so we're going to tackle the first challenge for tonight, which is going to be the pyramid challenge using recursion. And now they're not asking us to build a pyramid that looks like this. They're just asking us how many blocks are in a pyramid with a given height. A pyramid looks like this, right? And so if a pyramid is 4 rows high, it looks like we'd have 6, 7, plus 4, plus 3, plus 1. So if I'm counting right here, that would be, what is that? Sorry, did I count that right? That's 4, 7, plus 5 is 12, 15, 16. Sorry, so I said 4, but that's 5. But notice how we're basically each row deep, like we're adding another 1 to the end, right? So we've got 1, 3, 5, 7. With 5 rows, it'd be 9. If we had a 6th row, it would be 11, right? And so the number of blocks for a row n equals 2 times n minus 1, right? So row 2, 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, and then 8 minus 1 is 7. All right, so let me go ahead and fork this. And let's get to work. All right, so let's go ahead and add my method call. And we'll start off with a height of 4, because that's what the instructions use. So I need a base case and a recursive case, right? And so I want to hit, I typically want to spell out my base case first, right? And so does anyone want to take a stab at what my base case would be?
N equal 1?
Yes, so we're not using n, but we're using height. So it would be height.
Right.
If height is equal to 1, then what do I want to return out of here?
1.
Yep, so basically if I hit row 1, I know that that's basically going to be 2 times 1 minus 1 is 1. So that'll always be 1. Like that doesn't change. That'll always be the top layer. Oh, come on. There we go. All right, so now for my recursive case, right? And this challenge is nice enough. It gives us the recursive case, right? So we've got 2 times height minus 1, right? And so what I'm going to do here is say return 2 times height minus 1. And then I need to basically, this doesn't move me any closer to my base case, right? So if I do a height of 4, this would turn to 4. 4 is not equal to 1. So it'd come down here and say 2 times 4 is 8, minus 1 is 7. And then that's it. Like that's the end of it. There's no recursion here yet. So for it to be recursion, I have to make another call to my function, right? And what do you think I want to put as a parameter for this recursive function call? So if I was in a while loop and I wanted to decrement, right? Like, so how would I decrement this function call in my recursive?
Should it be a block notation, like block height?
Well, no block or box notation, because we're not using an array. We're just using a number here.
Well, it should still be height then, height minus 1.
Right. Yep, absolutely. Because this moves us closer to our base case, right? So the first time I come through here, this is going to be 4, right? Height is not equal to, or 4 is not equal to 1. So we come in here, 2 times 4 is 8, minus 1 is 7. And then pyramid height minus 1. So 4 minus 1 is 3. And then we basically call the function a second time, this time with 3 up here. And we keep going through until we hit 1. When we hit our base case where we return 1, and then this becomes 1. And then this would be 2 times 2 minus 1 is 3. So 1 plus 3 is 4. And then we keep returning all the way back up the call stack. And for those of you that go to Code Platoon in person, I don't know if they still do it, but they form a human call stack, basically. Like they make everyone get in line and memorize a part or memorize like a easy method like this, and then physically count off and work their way through the call stack just to kind of drive the point home, right? But there's our 16, right? And which is exactly what we're looking for, right? 1, 3 is 4, 4 and 5 is 9, 9 and 7 is 16. If I kick this up another layer, right, there's my 25. If I kick it up to 6 layers, I would expect that I would get 36, right? And then this should be 49, right? And there's our 49. All right, so we're looking good with this. So you can see, and we're basically, recursion is just a fancy way of replacing a loop. And the 2 things that you always need to identify is where is my base case and what is my recursive case. And you just need to remember that your recursive case, every time it iterates through, should be moving you closer to your base case, right? So in this instance, if I'm calling in a height and my base case is 1, every time I call this, I need to do something that moves the next function call closer to my base case, right? Because this is first time through is 7 minus 1, the second time through is 6 minus 1, then 5 minus 1, 4, 3, 2, 1, so on. And when I hit that 1, I hit my base case, right? And so those are like the two main components there. All right, so let's go ahead and look at reverse a word in recursion. So using recursion and without creating any additional variables, create a function that returns the reverse of an inputted string, right? And we don't need to worry about capitalization, anything like that. It'll just be exactly what comes in, goes out the other end. I mean, don't need to remove special characters, anything like that. So if there's a period, everything stays. You're just reversing the index position of it. So hello becomes OLLEH and so on. So this is reverse word for recursion, and I'll dump that into the chat. And let me go ahead and all right, so we're going to do the reverse word with recursion. So using recursion and without creating any additional variables, create a function that returns the reverse of an inputted string. Right, so we want to be able to turn hello into Ola. And so we've got one parameter coming in, which is going to be my in order string. All right, now when we think about this, so I need to basically access my string and then remove a letter from it and keep that letter isolated from the rest of the string, and then call the function recursively Okay, so I know because I need to get my string and I need to basically chop a letter off each time that I'm going through here. I know that my base case for this is going to be an empty string. All right, and now I saw alternatively, okay, so both of these are valid, but this is a little bit longer. I'm calling an additional function. I'm converting my string into a number, which is representative of the length. So this is a little bit quicker just to do it this way. So, but either one will get you to where you need to go. And then, so for that, with my base case, I'm going to return an empty string. Now, if my else case is, or I'm sorry, so my recursive case or my else case here is going to be if my in order string is not an empty string, I need to go down here. Now, remember, there's two things that we're going to do here. So we're always going to recursively, oh, that's spelled wrong. All right, so basically I know I'm going to need my recursive call plus something else. All right, and in this instance, I'm going to be, my something else is going to be equal to a letter from the string. All right, so return, and we're going to return the reverse word, right? And we're going to feed in the in order string again. And if I want to remove, so remove letter from string JS,
geeks. Geek for Geeks is usually pretty good too. Man, MDN is failing me here today. So basically what I'm looking for, and I guess I can check here. Yeah, replace method, replace. Yeah, no, I don't want any of that because I typed something wrong here. Remove. Oh, the internet. So anyways, what I'm looking for is string.prototype.slice. Ta-da! It was right there in the top of the results. So basically what's going to happen here is you can do start stops. It is exclusive. So if I start at the 0 position, right, because it's inclusive, I get the whole thing. That is like writing an infinite loop. There is infinite recursion. I'm never getting closer to my base case, right? But if I start at 1, then I get everything except for the first letter, right? So back in here in reverse word, I'm going to call it as hello. And then, so I'm going to have hello, hello, LLO, LO, and O, right, as I recurse through here. So I can do dot slice 1. And not ret run, how about return? And then if I want, and basically, since I'm passing this with the first letter chopped off, I need to represent the first letter somewhere. So that's just going to be in order string box 0. So that 0 index position, right? So this becomes, I don't need all these extra spaces. Right, and then the next time I call through here, oh, that's twice in a row. Right, so there's my empty string in my base case. Right, so then I add back in the 0, then I add back in the L, the E, and then the H. Right, and so that's how this goes through here. All right, now, Courtney, you had asked earlier if this order matters. And I said in that specific example, it didn't, but in this example, it will. Right, and I made this mistake my first time through as I was working this problem out. Right, and so now I'm just adding it right back in the same order. So I tore it apart and I came back and just added it all back in the same way. So sometimes with recursion, it will matter, sometimes it won't. It just depends on the problem that you're working with. Right, but that's how we reverse it. And so again, lots of notes here, but if we clean this up without the notes, there's not a whole lot to it. And it ends up being a fairly small method at the end of the day. All right, so any questions about how we got here with this one?
I do have a question, yes.
Go for
So so how would in line 19, how would in order string ever know it's an empty string? Because from what I know, when you slice, you don't mutate the original string. You make a shallow copy of it. So how would it ever reach an empty string?
You are correct, but what we're doing is calling it with the shallow copy, which then becomes in order string, right? So at the end of the day, hello in correct order is still there, right? And like you notice, we're not returning in order string as like, we're not just returning in order string, right? We're returning a method that's being fed in order string with a single index position of in order string, right? So even though this only makes a shallow copy of in order string, the original one that's fed in, we're still feeding it into this method call. So the second time we call it, it only sees this, right? And then the third time we call it, it only sees this. Fourth time, fifth time, sixth time.
Okay, I think I get it, yeah.
Okay, yeah, because we're not just passing, because if we did this, right, this would be an infinite loop, or not. Oh, that's because I've got this one down here. All right, so there's my maximum call stack size. I exceeded, right? Because I'm never getting towards my base case. Right, so at this time, every time it goes through, we're passing it a copy, so it doesn't have to have the original one. We're passing the shallow copy in, but that shallow copy is slightly smaller each time.
That makes sense.
Okay, cool. All right, so there's that one. And so let's go ahead and look at the next challenge. Is everyone doing good? We're ready for the next one. Does anyone need to take a quick break? Okay. So this one is going to be a little bit of math involved, right? So we got some modulo. Euclid's algorithm for finding the greatest common denominator, GCD, for two integers is GCD AB equals B if B evenly divides A, right? And so that basically turns into B remainder of AB, i.e. A modulo B. So they're kind of giving you what you need to do otherwise. Write a function using recursion to implement Euclid's algorithm and return the greatest common denominator of two given integers. Right, so GCD 30 and 12 is 12 and 6, and then 6. All right, so let me just check one thing here real quick. Okay, so I'm going to open the breakout rooms back up again, and we'll get kicked off on this one. We should be able to look at this one for, it's 8:07. I'm going to give everyone about 15 minutes to look at that, and I'm going to pull it back and I'll go over it in class. It'll be about 8:30, and that should give us time to do one last challenge tonight. Any questions here before I set the breakout rooms up? All right, here we go. All right, so for you guys crushed the last challenge, the greatest common denominator. Diz, like I said, yours is a little bit different than mine, but I mean, they both still work. So, I mean, multiple ways to get the same thing done sometimes. One other thing, and actually, I guess before we hop into the palindrome, let me throw this one out here, and I'll clear this out here real quick. So, factorial is a notorious interview question, right? Like, this is a whiteboarding question. This is like, you could get asked to walk someone through this over the phone. Like, if you were basically, if you had to pick one algorithm to memorize going into a junior developer position, it would be like this one. It'd be like a toss up between this one and FizzBuzz, basically. Like a super high probability that you're going to run into one of these two. And so write a recursive function that takes in a positive whole number and returns the factorial of that number. For reference, the factorial of the number is each positive whole number up to and including that number multiplied together. All right, so we're doing multiplication. So like a factorial of 5 is 1 times 2, 1 times 2 times 3 times 4 times 5, which is equal to 120. Right, and so with anything like this, we need a base case and we need a recursive case. All right, so for my base case, I'm going to say if num is equal to, or we say less than or equal to 0, then because we're doing multiplication, remember, we just want to return 1 because there's no impact. Any number times 1 is still that number. If we return 0, we would 0 everything out because any number times 0 is always going to be 0. And so for my recursive case, I'm going to return factorial. And I've got my num. Remember, I need to move towards my base case of num being less than or equal to 0. So we're going to decrement here. We're going to subtract 1. And then we're going to multiply it by num, right? So first time I call this is 5. 5 is not less than or equal to 0. So I skip my base case. I come down here. I'm going to call factorial 5 minus 1 and then multiply that by 5, right? So this in essence is 4. And it keeps getting fed through all the way down until we hit that base case of less than or equal to 0. Then we return 1. And so 1 multiplied by 1, by 2, by 3, by 4, by 5, which will give us that 120, right? And there's the 120. And so if I did 6, what is that going to work out to? That's 600 plus 1, so 720, right? So there's 720. 7, it's going to be up there around 4,900 and 5,040. So this is a very straightforward until you're standing in like a whiteboard in front of like 2 or 3 people and they ask you to write through it. So like this is one that you can drill on, you can practice. Like you should be able to, by the time you leave code platoon, someone says like, show me how you'd like write a program recursively to give me the factorial of the number. Like you should be able to do this with your eyes closed. All right, so now on to the big one, so palindrome. All right, so slightly larger problem. We're gonna tackle it the same way though, right? So I know I need a base case and a recursive case. All right. Anyone want to take a stab at what my base case would be? Is everyone familiar with what a palindrome is? So it's a word that's basically spelled the same way, both forwards and backwards.
So should it be if race car is equal to race car? Return word?
No. So basically, so this is going to draw on the same thing as the reverse a string, right? Because if we fold race car over on itself, right, on the E, right? So E and then the C's and then the A's and then the R's, right? So what I'm looking for is, and so remember, we decrement a lot when we're doing the recursion. So we're moving towards our base case, right? So what I want to do is say, right, so the first time I'm calling this, I'm feeding in race car, right? So how, and what I'm looking for is R and R equal to each other, right? So if they are, then R, get it, R, haha. Then I can chop those off and I want to look at the next two sets of letters, right? So are those two equal to each other? Yes, they are. Right, and then because this is an odd numbered, or there's an odd number of letters in here, I just have E, right, in the middle, and that's fine. E is equal to itself. So this would be a palindrome, right? Now, the other portion of this, and so we're going to, they put an evil olive in here. So we're ignoring spaces, right? So just for the, well, let's see here. That's fine. What is a even lettered palindrome? Yeah, these guys are killing me. Okay, so peep, noon, any longer ones? Okay, whatever, peep it is. So back in here into palindrome. So if I call one of these, right, it's the same thing. I'm going to do peep, right? So that's an even numbered palindrome. So those are, this one actually has two base cases, right? So if I can make it all the way down so that there's only one letter left, or that there's no letters left and all the other letters were matching, that's my base case. That's where I return out of there. Right, so that's true. And my recursive case for this one is going to be return okay. So when we did the sorry, so when we did the reverse word, we were just slicing a letter off one side, right? So now I'm in a situation where I need to slice a letter off both sides. Right? So when we go back to slice, right? So I can give it just a start position. I can give it a, oops, sorry, this is array slice. There we go. So I can give it just a start position, or I can give it a start position and an ending position. So now I want to basically call my method an additional time recursively missing the first and last letter. What would that look like?
Would it be 1 and -1?
Yep.
All of them. All right.
Yep. So I could do 1 and -1. Oh, sorry. Do a comment there. So if we take a look here, right? So if I say, let me just comment these out. And this one. So if I say console.log, right, Charles.slice 1, -1, right? Now I'm missing the C and the S. And I highly encourage you guys to do this, right? Like if you don't know what's going to happen when you do something, test it out, right? You don't have to pay a nickel every time you click the run button. You just throw things in there. Most of these problems, when I kick you guys out into a breakout room, I'm then solving it on my own. And I don't know necessarily exactly how it's going to work out, right? Like when I was doing the reverse word, my first time through, I had my in order string over here, and I was just basically building the word back together the same way I took it apart. So I mean, it's free to experiment with all of this stuff. All right, so let's go ahead and get rid of that. And let's also do this for right now. Okay, so, and then we will have that, and we also then need to, because remember, we got rid of the first and last letter, just like in that reverse word, we need to do something with those, right? And that is basically, we need to check to see if they are equal. Because if right at the very first, so like conifer, we know like right from the very beginning, the C and the R are not the same. So we know that it's not a palindrome right from the first go. And so here we can say word dot slice 1 right? So those are our two, or I'm sorry, what is it? Is it just -1? So let's see here. I think it is. So if I do console.log Charles dot slice -1, right? So that's just the S, right? So I need to then basically take that first letter that I chopped off and see if it is that. And then each time all the way up through here, all of these eventually have to get to the point where they return true, return true, return true. And if at any point, any one of them return false, that false will keep getting pushed back up the chain. And then the whole thing will be false because they're both not true. Yep. So let's see here. I think this is also going to be one where order matters. No, okay. So console.log palindrome race car, return word dot slice 1, triple equal to word dot slice -1. Let's see here. Why are we blowing up on restart? We blow up across the board. So this should be true. Okay, so this is returning, so race car is returning false, conifer is returning true, help is returning true, evil olive is returning false, and peep is returning false. So somehow I have inverted what I've got going on here. So palindrome, word dot slice, 1 -1, return, word dot slice. There we go. And so what was happening here was, because I didn't give it a start of 0 and an end of 1, and basically, here, I'll show you. So I'm actually, so when I had this, if I just do 1, right, I'm actually not grabbing just the C, I'm grabbing basically Charles with everything except for the C. Comment those out.
Line 7 has a comma.
Line 7 has a comma, thank you. And right, so I was comparing this, so the rest of the word. And so what I actually needed to do was give it a start of 0 and an end of 1, and then I'm grabbing the C. Right, so same thing up here. And now we're getting what we need to out of this. Sorry about that. But again, there's, and I make mistakes all the time. And the big thing is that you are able to work through your mistakes and kind of diagnose what's going on with them, because that's all this problem solving is I mean, it doesn't matter if you don't have anything or what you have is broken, you still have to figure out what the next step is going to be to get towards the end. All right, so it is 8:40. Let's see here.
Did he freeze?
No, I didn't. Sorry, I was just looking at something. Was trying to see if there was another one that we could knock out here in the last 20 minutes. I guess there is this one, which is not recursive, but it does touch on, I mean, this one isn't anything special, right? Write a function that takes in any data type of any length and returns whether or not it's truthy or falsy. This one's super simple. It's basically what I wrote in the notes up here at the top. Like, this will take anything, and if you just let it resolve itself, it'll either resolve as truthy or falsy. So the last kind of ones that we have to work on are going to be longer ones, and I was planning on tackling them tomorrow. So I guess what I'd say is I'd open it up to questions at this point. As far as anything that we covered tonight, anything so far in the course, happy to answer them. And then tomorrow, like I said, we'll tackle the employee data objects or employee data, and then also the little code platoon pre-work algorithm that I got to play with today. So I'm going to go ahead and stop the recording now.